Dovetail cutters are finally here. These are eBay special 55-degree dovetails, direct from Hong Kong. I wasn't quite exactly sure what quality to expect, for the import cutters and what they cost. So I got two just to play it safe. These are 1 3/8. They're 35 millimeter by 1/2 inch sort of cutting with 16 millimeter shanks. Though I was pleasantly surprised, they look pretty darn good. They don't feel like the sharpest things in the world, and I haven't actually measured to see that they are exactly 55 degrees. I don't think it's going to be all too important, just because I think we're going to be milling most of the faces anyway, so as long as the angles are all consistent between all the mating surfaces, it shouldn't be a big deal. So we can finally get to work on the saddle. I thought while I was here I would do a little bit of show and tell of some other stuff I got. A little piece of carbide, and we'll be turning this into the small scraper to get inside those small dovetails, and I'll take you along for the ride. We'll cut little pieces off, braze them on, and sharpen them. Hopefully we can get something small enough that cuts that gets into those dovetails. I also came across a good price on a used interrapid indicator. I only know about these, by their reputation. People consider them, I think, they're like the Rolls-Royce of dial indicators. This is a half thou indicator. My go-to indicators have always been this set of peacocks that you've already seen in the other videos. This is a 5/10 and a 1/10. These have seen better days, but I still trust them. They're a little bit rough to get started when you're trying to adjust. It needs quite a bit of sort of start force before it slips and gets moving. One is a little bit better than the other. You probably can't feel that through the video, but take my word for it. This, on the other hand, and I haven't actually used this other than just playing around with a bit on the service plate and just general feel. It's got a larger face right off the bat, and the numbers are a lot easier to read. The motion of the bezel is just silky smooth. The only twist within this interrapid indicator, and it's just I guess a matter of me getting used to it, these indicators always have, or this indicator, this style peacock indicator, always has deflection measurement in the same direction. If I pull it up, it goes clockwise. If I push it down, it always goes clockwise. The interrapid, and maybe it's just the style that I purchased, I'm not sure. If I push it down, it'll go in one direction, and if I pull it up, it'll go in the other direction, which intuitively probably seems to make a lot more sense. But again, I'm just so used to that style indicator that this can take a little bit getting used to. So I'm really looking forward to working with this one. It'll be a lot easier on the eyes, a little less hassle. It's got these nice friction sort of built-in stem. The other thing I came across that I couldn't turn down is the 5 to 6 inch micrometer that I was missing. Came in a nice box with a standard. You can't quite read that. It does say 5 to 6, and it reads to tenths. This particular one is made in Brazil, which I didn't know they did, but I don't know, good condition, the price is right, and I filled that gap in my set. Also picked up a small selection of grinding wheels. Most of these were eBay, of different flavors. So this must be grape, cherry, blueberry. I suppose that'd make this lemon of some kind. Anyway, that's getting ahead of ourselves just a little bit. So let's talk about machining the saddle. We have the cutter, and we know we need to take the matching 10 thou off of this surface and bring this surface into match. This surface doesn't have as much wear, but they'll obviously have to end up on the same plane along the length of the saddle. So the plan is to come in with the dovetail cutter, surface both of these bearing surfaces for the table, then come in and dial in, sort of touch off on the high spot. We know there's bow in the middle. That's what the preliminary measurements are for. Touch off on that high spot and start to machine that out, until we get, hopefully not all the way to the end, because that just means a lot more material to remove, but, I'd be happy with 1/2 inch shy of each side, and then, whatever comes down during the scraping process, move to the back and do the same thing on the back side. Something else that I noted is that the inside of these dovetails, Doesn't have really any relief. It's sort of a rounded inside corner. Actually, the cutter touches off on the tips first. It's not a big deal for the table because it's got the matching clearance on the sort of the high side of that dovetail, so it never reaches into that corner. So what I'm considering doing is coming in here with a saw and just cutting some of that, a small relief groove in. I don't think that's going to take any real strength away from this. You know, it's a small surface grinder. And again, it's not really necessary for the table, but I'm going to need that space in there in order to be able to scrape into that corner. One last twist. We'll do the slitting on my mill. We'll do some of the other clearancing work on my mill. But I've decided to take this end mill, the dovetail cutter, and the table over to a friend's place not too far away from here. Like I said in the preceding videos, my mill's got some funky wear in it. Funky for me, I'm sure they probably all wear the same strange ways. Because this piece is so long, you know, and I'm using such a large envelope of the mill, and I'm essentially cutting two simultaneous surfaces, you know, I can surface this out here without any problem, but when I move in, I'm starting to cut sort of on the floor and in the dovetail simultaneously. This will turn into some really complex surfaces in here because of the wear in my mill, and it sort of defeats the purpose of machining to a truer surface. I mean, technically the machining process, I suppose, isn't necessary. You could scrape this 10 thou out, this, you know, 5 thou deviation out. To get 10 thou out, well, I mean, you do the math, that's like 50 or 100 passes of scraping. This is more just a cleanup to make, you know, our life with the scraper a little bit easier. And in that vein, it makes sense to eliminate as much of the wild cards as possible. And the biggest wild card in this process is my milling machine. So we'll take it over to a friend's place. I probably won't be doing too much yapping there just because, you know, it's another guy's shop, and maybe I'll talk over it or just give it some subtitles. I think it should be relatively self-explanatory what we're doing. Then we'll bring it back here and start spotting and scraping and trying to match all the surfaces up. For now, let's try to get this gutter cut in here. I've got this, it's clamped on each end, and it's raised off the table with some parallels on the dovetails of the knee. And those are a little bit warm too, so I had to futz around a little bit with the indicator, and I picked up this surface, and I just tried a few other surfaces, you know, tried to catch some edges to square it up. Where this groove goes isn't uber critical. This saw is thin enough that I'm hoping it follows the path of least resistance, so any error I've got, you know, it should relieve that groove. At least this thing does, you know, every time I don't want it to do that. So I'm hoping it will now that I want it to do that. But I think I'm actually pretty darn good. It's hard to estimate sort of the depth of cut down in that corner, but it's maybe 100 thou, something like that. I think that should do it. It's probably impossible to see down in there. Maybe an end view. Just a little bit of relief down in that corner we can scrape into. I'll try to get some better shots. I'm sure we'll see it while we're scraping the thing in. Okay, it was a couple of days ago, but I think in the YouTube world you would have just seen me recut these dovetails. Sorry I couldn't, say too much, or I didn't say too much during the process, but again, I was at someone else's place and I was sensitive about how much time I was taking up on their machine and just sort of being in their space. I don't think it was a problem technically, and it came back to bite me in the butt, actually. So I made a couple of bonehead moves. I tried to point them out sort of in sign language during the video, but we'll cover those here in a second. The dovetail cutter held up surprisingly well. I didn't find any hard spots, no weird, refills in the casting. A couple of very small voids are starting to pop up, but they're minuscule. I spun the cutter at I think I started at about 200 RPM with a very conservative feed rate. It cut very nicely. I ended up going to about 400 RPM and a relatively aggressive speed. That machine he's got is just a beaut. Very low hours, essentially right out of the box. What you didn't see in the video was just checking his machine out in general, making sure the head was trammed in and everything was nice and square and moving accordingly. Total cut time on this, wow, couldn't have been more than 15-20 minutes, and I expected to just take up about an hour of the guy's machine time. Now he's a hobbyist, so I'm not causing any major problems there. Setup on that machine, or just setup for this thing, and I'm not sure why, because I've put this on my mill, and within a few hammer taps I've gotten these references in. It took me the good part of probably an hour and a half to tune this in on his machine. I don't think my setups were lying to me. Again, the indicator's standing still and everything else moving underneath of it. I think it's just maybe how it goes sometimes. So after the 2 hours of trying to get this thing set up, I was a little bit pressed for time, to actually get the machining done. And the first thing that happened that I caught relatively quickly, and I think I highlighted this in the video, I haven't actually watched that footage yet. I knew I was taking 10 thou off of this surface. I put my cutter down on this edge, zeroed it out, dropped it 10, and started to cut when I realized that the high spot was in the center, and that's where I needed to zero my cutter out, come off the side, drop it 10, and clean the surface up. Anyway, we'll just keep that between you and me. No one's ever going to see that. It definitely could have gone bad fast if I hadn't caught that in that first quarter inch of cut. So you think a close call like that would have been a wake-up call, but I ended up making the same exact bonehead mistake on the dovetails. This could have gotten bad very quickly. I mean, as it were, I took too much material off. We established that this had a bow in both sides, thinner on each end and larger in the middle. What I did was I came into this end, zeroed on the worn section, came in and took that 1/8 thou off when I should have done that in the center. If that wear was more, I don't even want to think about what could have happened. That said, the actual geometry came in surprisingly well, and that's why I went over and did this on a new machine. I'm within 1 thou along the whole length. As it is, this saddle now and the little bit of work we did on the table, this machine is already, 10 times better than how it started. If nothing else, I at least now have the full motion of the table, whereas before I couldn't go more than 6 or 7 inches before I was really cranking on the hand wheels to get into the last, the extreme ends of this table. So now that we have these machine surfaces, and these are pretty darn close, I've checked them preliminarily on the surface plate. His mill was spot on in keeping the Z depth at the same place. Cutter didn't budge, so these surfaces are golden and just sort of need to be scraped in. Now to take these measurements with the new Brazilian micrometer, I'm using the same pins that we used before, correct size for the dovetail, and I've got a couple of small Joe blocks just to keep the anatomy of the micrometer off of off sort of these little shoulders, and I just come in. Oh, sorry, that was the other way around. Take that micrometer reading and do the same thing down the length. So there's the full shot of what it looks like with the micrometer across it. So I've measured 4,678 on this end. You probably won't be able to read that on the micrometer. And I did that in a few spots. Just marked the extremities, and here 4,688 against 4,678 for a thou of difference along the length. Which again, I'm very happy about that compared to what we started with here. So 1 thou deviation in the dovetails is good news for me. But unfortunately, it's only half the story so far. We don't know where that 1 thou is in terms of, parallelism with the whole machine. Let me see how I can explain this. The motion of the table here needs to be 90 degrees with respect to the dovetails down here. I don't know if you can see those. There's only half a dovetail here, mating half bolts on. It's the gib. So this dovetail surface, this whole bearing guide surface, needs to be perpendicular to these dovetails. Let's see if I use some visual aids here. We've established that there's 1 thou discrepancy between these. Now we don't know if it's 1 thou on one side, half a thou. We know just the general shape of this. So practically, I have no idea where to scrape, where to take that 1 thou off. It's been quite a head scratcher trying to figure out how to check the perpendicularity of this axis with the perpendicularity of this axis. And off the cuff, I thought, I could somehow use some squares to get in here, come across the dovetails, and somehow measure, to the surface that's below here. But I wasn't able to quite figure that out. Like, how do you get from this geometry that's 2 inches deeper up to these dovetail ways and be able to repeatedly scan along the length? So after quite a bit of noodling, I did some fooling around on the surface plate, putting it in different directions, trying to pick up reference and surfaces and sort of infer where the deviation was. I had the idea to try to measure this directly on the machine itself. So I had to reinstall the knee, put the saddle back on, and the idea was to use the rotation of the spindle that's driving the grinding wheel, which should be, perpendicular also to this table motion, to these guideways. I could use that since they're sort of on the same side. I don't have to get from one side to the other. And do the same type of measurement across dowel pins. So come down, use the spindle, spin the spindle, and pick up the other dimension, and get a sense for where that 1 thou lives in these dovetails. Now I've actually done that, and I'll show that to you in a moment. The good news is, I think I know where most of that deviation is, and it seems to happen on this side. I was getting measurements consistently between 3 and 5/10. So that means, the rest of the 1 thou is over here somewhere. I think seeing the setup and the measurements happen will hopefully make some more sense. So the idea is this, and I'm pretty sure this should give me a good picture of how that wear is distributed in the dovetails. I've got my indicator, it's currently pointed horizontal because it would just crash. I've got the indicator mounted just on a piece of 1/4 inch stock, and it's clamped in, where the grinding wheel would be clamped in, and I can swing it freely. The saddle's back on the knee, and the knee is back on the machine. I'll give you a different view of that. And I've got dowel pins here. Now I'm not sure how to film this because I essentially need 2 hands to do that, and then I would need a 3rd hand to move the camera around. But fundamentally, holding the pin and slowly sweeping it, looking for the high spot on the indicator. I zero that out, swing this across the top. I'm trying not to touch that beam or influence the table in any way. I mean, we're trying to measure down to tenths here. And, from the other side, essentially do that same thing and take that measurement. I'd be holding the pin in place. But let me grab the camera and I'll give you a different view of what's happening here. The indicator's in the clamp. The beam comes up and it's just sandwiched between the washers. There's a little spacer block there. Allows me to spin that. The saddle is in a position, you know, I'm going to try this in different positions off camera, but you know, sort of in a neutral front to back position. I assume there's more wear at the front than there's at the back, but I don't think that should affect our squareness measurement. You know, if anything, it would affect, you know, the front to back dip. And that's been bumped up against side, so that dovetail is running the show. I don't have the gib in this side. And the knee is back on the table. Now the knee is about the position, so if I had the table on, magnetic chuck, and a 7-inch wheel, I'd be grinding maybe like a 1-inch stock. So that's, you know, I just eyeballed it about that height. The screws obviously aren't in this machine, and I just put some spacer blocks in there. As I tighten it, I just sort of try to tap everything so it settled into position. And that's how I'm taking the measurements. And I think this should get my saddle square to my spindle, and hopefully that's already square to the knee. I've already taken a few measurements here. I've done this quite a few times now. I'm consistently zeroing over on this pin here. And I swing over and I measure the contact with this pin here. And I mean, it's a half thou indicator, so it's a bit hard to read, but I'm measuring consistently anywhere between 3 and 5/10. Now that's not the same place I measured the 1 thou with a micrometer, so I'm going to have to do a little bit of math to figure out, you know, what it is in the same place that I measured that 1 thou with my micrometer. But if I assume that's, I don't know, on average 4/10, you know, maybe that's 6/10, that's 6 here and 4 here. I'll probably measure this again in the back. You know, I'm going to have to bend a new support rod to keep the table in the same position to be able to sweep here. I'll try to verify that in the back. But I'm not trying to go nuts here. Like, you know, a thou is a little bit too much over this whole length in terms of taper between the dovetails. In terms of squareness, I mean, the original spec for this machine when it was brand new was 1 thou over the whole, you know, working space of the machine. If I get anywhere close to that, I think I'd be happy. So what it's looking like is, you know, we'll be step scraping again, taking about that, you know, starting to get that 6/10 off of here and running that off to 0, and then using this to take this side in parallel, which is going to be, you know, 4/10 back there. Depending how this all goes in, I may just do a cleanup pass on the back and, you know, not try to go too crazy here. Hope that made sense. So here's the end view of, you know, the table, gib, and saddle stack up. Sorry, I just wanted to step away and grab my marker. Now, I still haven't taken the top surfaces off the saddle yet. And in fact, I've got about a 10 thou gap in there. I don't know if you could see that. That's the 10 thou we took off. You see the step here between the table, where the table and the saddle. All of this material that came off extra bumped my table, you know, towards the operator side a little bit. And now I have larger gap in my gib side. What I do is get some longer screws. I don't think my screws can take up this much adjustment. So the next step here is to take off the top of these. These are non-bearing surfaces. I just need to add that clearance back in. We'll take the tops off of those, and then we'll, you know, once these things are seated, we'll take some more measurements. I want to make sure that this top surface, I want to see how this top surface is in relation to the bottom of the saddle dovetails. Back on the mill table, same setup as before, the clamps on each end and the parallels on the knee dovetails. Just indicated it in. I mean, I had to go through tramming the head and all that kind of stuff. So what we're going to do is take the clearance cut on these surfaces. I think about 20 thou should probably be fine. We've got 10 thou interference now. I figure an additional 10 thou clearance should be more than enough. I'm also going to take down this surface here. This is where the sort of the cross feed screw and all the small table mounts to the front. we're pretty darn close. I just don't want this to interfere with any of the spotting we do on this surface. I can take this down and then if I have to, just put a 5 or a 10 thou shim back in. Alright, so that's it. I guess nothing really to write home about on that one. Took about 20-25 thou off the front and back, and about 10 thou off the support surface here. Just enough to not interfere with the spotting on the bearing surfaces. I'm going to just vacuum this out a little bit. We'll take it over to the bench and just break some of these sharp edges. There's the clearance we just cut in on both sides. And you might not be able to see it down here, but here's the little attachment point for the small table and the crossfeed wheel. So before I wrap up this third installment, I thought I'd answer or address a question I've gotten that I think is a really good question, and why I'm not rebuilding the entire machine. That's certainly an excellent question. I just want to get this thing work. I just want to have fun with this machine. From what I've been able to tell in the little use that a little bit of playing that I did before I decided to break it down, the majority of the wear, at least for what I appear to be doing, as a hobbyist, was in this table, getting this travel back, and just getting the top part of this machine tighter. Most of the wear seemed to be here, not so much in the table and the knee, though certainly I don't have all of the range of motion that the machine originally had, so there's certainly wear there. Reason number 2, I don't think this list is too long, is moving away from the table starts to get into some more complicated measurement and sort of analysis of the machine. We're starting to talk about checking perpendicularity between the knee and let's call it the column, and then all of that needs to be parallel with the spindle. And it adds it's a bigger step, I guess, than I'm really comfortable with just right now. Certainly, what we'll do is what I'll do is I'll put this together, put the chuck back on, grind it in, and just play with it like that. And if I start to see problems, I'll at least have a better indication of exactly where that is, since we've eliminated the table itself. So if I'm getting weird tapers or different thicknesses, I think I can infer where most of that wear is. Item number 3 is maybe a little bit more long-winded. I'll try to explain this to the best of my understanding of it and as concisely as possible. When we're scraping a machine back in, again, I don't want to sound like I know more than I actually do. This is very much an exploration process for me. Scraping is a machining process, just like milling and turning. So we're taking material away. Now, as I take material off this interface between the table and the saddle, the table is dropping. We've already dropped it 10 thou, if not more, between what we'll end up doing in the scraping. Let's call it 20 thou that we dropped this thing totally. That 20 thou now needs to be compensated for in the controls of this machine. So I'll show you what I plan to do to make up for that amount of material loss on the table, but I think what I'm trying to get to here will be more evident if we look at this the infeed screw on the saddle. So the tables run back and forth with this pinion. The pinion interferes with a rack that's mounted on the bottom of the table. Here's the rack that I took out. So if I were to assemble this as it is now, the scraping's not going to take very much off. I assume this would be an interference between the rack and the pinion. So what I'm going to have to do is take let's say that 20 thou that came off of from everything we've done so far, off of the bottom of this rack. So when I screw it back into the bottom of this table, I don't know if you can see these holes down in here, we'll have the original clearance and the table will still move. The same thing would happen between the saddle and the knee. If we machine the bottom of the saddle and the top part of the knee, that whole stack up will drop, by however much material we leave here. Let's call it again another 20 thou. That's going to take, this is sort of the in-feed screw that drives the table, and it screws into there. What we'd end up doing is dropping that table 20 thou, and now the screw and the nut no longer line up by 20 thou. So as you move in, it'll start to bind up, and you're basically not aligned anymore. So you'd either have to modify the mount for the screw, this side, where the handle goes, or you'd have to move the nut. Or I believe what traditionally happens is these surfaces get machined. You remove material away, and then they stick on stuff like Tersite or Rulon, bring that back up and scrape it back in to the original factory height. So all of the controls end up, in their nominal position. The same exact story goes for raising the whole knee in the table. If I scrape up against the back column and against the back of the knee, I'm going to move everything in closer, and then that screw will no longer line up. So the table was the low-hanging fruit here. This is a little bit tougher nut to crack. Not to say we might not eventually do it someday, but for now I just want to clean up the top half of this machine and get to playing.